By the summer of 1941, the German Wehrmacht appeared to be less of an army and more of an irresistible force of nature. To the observers in Washington, London, and Moscow, the German military machine looked like a terrifyingly efficient clockwork entity, a monolith of steel and discipline that had mastered the art of modern movement. They had dismantled the Polish defense in weeks, bypassed the impregnable Maginot Line in days, and forced the British Empire into a desperate maritime escape at Dunkirk. On the strategic maps pinned to the walls of the Oberkommando der Wehrmacht, OKW, the progress was breathtaking. Thick blue arrows sliced through the heart of the Soviet Union during the opening phases of Operation Barbarossa. These weren't just tactical advances, they were leaps of 50, 60, or even 100 miles in a single day. The world was witnessing the pinnacle of Bewegungskrieg, the war of maneuver. The German tank, the Panzer, became the symbol of this era. Whether it was the agile Panzer III or the more robust Panzer IV, these machines moved with a speed that defied the traditional logic of warfare. Behind them followed a logistical tale that, on paper, was a masterpiece of Prussian organization. Thousands of trucks, many captured from the French or British, alongside the standard-issue Opel Blitz, formed a continuous conveyor belt of fuel, ammunition, and rations. Supply columns stretched across Europe with what seemed like clockwork precision. If a division was at point A, the quartermasters calculated to the leader how much fuel would be needed to get them to point B. The mathematics of conquest were being solved daily by bureaucrats in Berlin. In the air-conditioned boardrooms and the quiet halls of the Ministry of Armaments, the war was already won. The production quotas were being met, the synthetic fuel plants were churning out oil, and the rail networks were synchronized to the second. But maps are two-dimensional, and paper does not feel the bite of the dust or the grinding of metal. On the ground, deep within the vast, unforgiving interior of the Russian steppe, something small was beginning to fail. It wasn't a failure of courage, nor was it a failure of grand strategy. It was a failure of physics, a microscopic rebellion of metallurgy that no general had planned for and no high-ranking officer in Berlin had even considered. In the hierarchy of military importance, certain things command immediate respect. A 12-cylinder Maybach engine is a marvel of engineering. A 75mm KWK-40 gun is a terrifying instrument of destruction. The thick, face-hardened armor plating of a Panther tank is a testament to industrial might. These are the components that get the glory, the parts that historians obsess over. But an army is not just made of its prestige components. It is held together by the mundane. It is made of bolts, washers, gaskets, and seals. The crisis that would eventually paralyze the German logistical spine didn't involve a weapon. It didn't involve an engine. It wasn't even a part of the tank's primary offensive system. Instead, it was a simple mechanical component used in almost every German vehicle, from the ubiquitous trucks and half-tracks that kept the infantry moving, to the heavy tanks and the massive artillery tractors required to haul the 88mm flak guns. It was the universal joint, or more specifically, the needle bearings within the drive shafts and transmission couplings. In the sterile environment of a German factory, these parts were considered consumables. They were cheap to produce, easily replaceable in theory, and generally ignored by the upper echelons of the military bureaucracy. The U-joint is the literal bridge of power. It is the component that allows the spinning energy of the engine to reach the wheels or tracks, even as the vehicle bounces over uneven terrain. It allows for flexibility in the drivetrain. Without it, the engine's power is trapped in the block, roaring with fury, but going nowhere. In the early years of the war, across the paved roads of France and the well-maintained highways of the Low Countries, these components performed flawlessly. They were designed for the ideal conditions of European theater warfare. But as the Reich expanded its reach, it pushed its machinery into environments for which they were never over-engineered. The part that cost only a few Reichsmarks to manufacture was about to become more valuable than a Tiger tank, because without it, the Tiger was nothing more than a 70-ton paperweight. The collapse didn't happen with a bang. There was no single catastrophic explosion or a grand black day for the German Transport Corps. Instead, it was a slow, agonizing erosion. By the autumn of 1941, as the summer dust of the Soviet Union turned into the legendary Rasputitsa, the season of mud, the frontline commanders began to notice a disturbing trend in their after-action reports. At first, they were dismissed as minor delays. A convoy of trucks carrying essential winter clothing for the 7th Panzer Division would be reported as stalled 20 miles behind the front. A week later, a battery of heavy howitzers would fail to reach their firing positions because the tractors towing them had simply stopped. The sight became eerily common, vehicles abandoned by the side of the road without a single bullet hole in them, no visible damage, no smoke pouring from the hoods. To a passing infantryman, they looked perfectly functional, yet they sat silent in the mud. When the field mechanics, the grease monkeys of the Wehrmacht, opened up these vehicles, they found a baffling recurring problem. The engines were often in perfect working order. They would turn over and idle beautifully, but when the driver engaged the clutch and pressed the accelerator, the power would not reach the wheels. The snap of a failed universal joint or the seizing of the needle bearings within the drivetrain had turned these masterpieces of German engineering into static sculptures. Initially, the high command was dismissive. They blamed the weather. They blamed the horrific, flour-like dust of the Russian summer that acted like sandpaper on every moving part. Then, as the rain fell, they blamed the terrain, the bottomless mud that placed unforeseen torque on the axles. Finally, in a fit of typical bureaucratic frustration, they blamed the soldiers themselves, citing driver error and poor maintenance discipline. But the reports kept coming. From the frozen outskirts of Moscow to the scorched Caucasian plains, the refrain was the same. The supply lines weren't being cut by Soviet partisans or Red Air Force strikes. They were being ruined from the inside out. The silent collapse had begun. The German army, the most mechanized force the world had ever seen, was being defeated by a small, steel joint that couldn't handle the reality of the world it was sent to conquer. To understand why the German supply lines disintegrated, one must look past the grand strategies of the High Command and peer into the blueprints of the German automotive industry. The universal joint, that humble nexus of steel and needle bearings, was victim of its own heritage. It had been birthed in the laboratories of a nation that took immense pride in over-engineering. In the context of 1930s Western Europe, these parts were the gold standard. The designers at Mercedes-Benz, Opel, and Büssing-Nagy had built their machines for the world they knew, the smooth, asphalted autobahns of the Reich and the well-maintained cobblestone roads of France and the Low Countries. In these environments, campaigns were measured in weeks. Distances were short, and more importantly, the infrastructure for maintenance was always within reach. A truck could expect a scheduled grease job and a bearing inspection every few hundred miles. Under these civilized conditions, the German U-joint was a masterpiece of efficiency. But the Eastern Front was not a civilized landscape. It was a mechanical meat grinder. As the Wehrmacht pushed deeper into the Soviet interior, the environment became a predatory force. The roads marked on German maps were often nothing more than dirt tracks that turned into viscous, thigh-deep slurry during the autumn rains. This was the Rasputitsa, the quagmire season. To move a 3-ton truck through this sludge required constant maximum engine torque. The needle bearings within the drive shafts were subjected to a level of shearing force they were never designed to withstand. Then came the winter. The Russian General Frost didn't just kill men, he killed metal. In temperatures that plummeted to -40 degrees, the specialized lubricants used in German joints reached their pour point, turning from a slippery grease into a solid, brittle wax. When a driver attempted to move a frozen vehicle, the unlubricated bearings would shatter instantly. The failure was insidious because it was silent. There was no warning light on the dashboard. A driver might be cruising along a rare stretch of dry ground when a tiny microscopic crack formed in one of the steel rollers. Within miles, the heat from friction would build up, the metal would expand, and the joint would seize. With a sudden, sickening crack, the drive shaft would twist and snap. In an instant, a mobile fortress became a roadside wreck. One broken piece, weighing less than a few pounds, could immobilize a convoy of 50 vehicles, blocking narrow forest tracks and leaving the entire column vulnerable to the biting cold and Soviet patrols. In a rational world, a failed part is simply replaced. On paper, the German logistics system had a category for this, Instandsetzung, or field repair. But as the war of movement ground into a war of attrition, the theory of easy replacement collided with the reality of a collapsing empire. The first hurdle was industrial capacity. The needle bearings required for these joints were high-precision components that demanded specialized steel and exacting manufacturing tolerances. Germany's ball-bearing capital, the city of Schweinfurt, was already struggling to keep up with the demands of the Luftwaffe and the Panzer production lines. There simply weren't enough machines or skilled workers to produce the millions of spare U-joints needed to replace those failing in the East. Even when the parts were manufactured, getting them to the front was a logistical nightmare. The German supply trains were already bursting at the seams with ammunition and fuel. To make matters worse, the Soviet rail network used a broad gauge, 1,524 millimeters, while the German Reichsbahn used the standard gauge, 1,435 millimeters. This meant that every single crate of spare parts had to be manually unloaded from a German train at the border and reloaded onto a captured Soviet train, or hauled the rest of the way by the very trucks that were already breaking down. But the most profound failure was, ironically, Germany's obsession with standardization. The Shell program had been implemented before the war to reduce the chaotic number of vehicle types in the army. It was a brilliant move for efficiency, but it created a single point of failure. Because so many different trucks, staff cars, and half-tracks now use the same standardized drivetrain components, a flaw in the U-joint wasn't isolated to one model, it was systemic. When the part failed, it failed everywhere. It didn't matter if you were a general in a horse staff car or a private driving a field kitchen, you were all using the same vulnerable bearing. Entire divisions found themselves paralyzed. It was a mechanical epidemic, and the Wehrmacht had no cure. Logistics is a game of dominoes. When the first tile falls, in this case a small steel bearing, the rest of the line inevitably follows. The breakdown of a single truck in a narrow Russian pass was more than a localized mechanical failure. It was the beginning of a logistical heart attack. When the lead truck in a convoy suffered a U-joint failure, the entire column stopped. In the vast, roadless stretches of the East, there was often no way to drive around the obstruction. Hours would be lost attempting to tow the dead vehicle or transfer its cargo. This delay rippled forward to the front lines. The fuel didn't arrive for the panzers, the ammunition didn't arrive for the batteries, the food didn't arrive for the shivering grenadiers in the foxholes. Without fuel, the most advanced tanks in the world, the Tigers and Panthers, were reduced to stationary bunkers, unable to maneuver and easily flanked by Soviet T-34s. Without shells, the formidable German artillery fell silent, unable to suppress the massed Soviet Ur-Ra charges. By the mid-months of 1943, Soviet intelligence officers and frontline scouts began to report a strange phenomenon. They would come across German units that hadn't been defeated in battle, yet were completely motionless.
They found tanks abandoned with half-full magazines, and trucks full of winter coats stuck just 10 miles behind the men who were freezing to death. The Germans weren't retreating in a traditional sense, they were simply stuck. They were a modern army that had been forced back into the age of the horse and cart because their high-tech heart had stopped beating. The Soviet commanders realized that they didn't always need to destroy the German spearhead, they just needed to keep it from moving long enough for the logistical rot to finish the job. The war was being won not by the flash of the bayonet, but by the slow, grinding death of a supply chain that had forgotten to account for its smallest of parts. By the early months of 1942, the high-octane optimism of the previous year had evaporated into the biting frost of a Russian winter that refused to end. In the rear area workshops and in the industrial design bureaus of the Ruhr Valley, a different kind of war was being fought, a war of data and failure analysis. Engineers from companies like Henschel, MAN, and Daimler-Benz were receiving crates of field-recovered components. These weren't parts twisted by explosions, but parts pulverized by friction. Among these engineers, a terrifying consensus began to form. They drafted a classified report stamped Geheime Kommandosache, or secret command matter, and funneled it up the rigid chain of command until it landed on the desks of the Oberkommando der Wehrmacht. The document was devoid of the usual propaganda. It stated the situation with a cold, Teutonic bluntness. Our logistical failures are not due to enemy action, but to a critical mechanical weakness in the drivetrain assemblies of the primary transport fleet, a weakness that is now impossible to correct at scale.
The report laid out the mathematical impossibility of the German position. The universal joints in their needle bearings had been designed for the continental standard, smooth roads and short distances. In the Soviet Union, these parts were being subjected to torsional oscillation and lateral stress 4 to 5 times higher than their design limit. Because the German industry favored high-tolerance, precision-fit parts, there was no room for the grit of the step. Once a single needle bearing cracked, it would ground itself into a paste, seizing the joint and snapping the drive shaft like a glass rod. The engineers offered a solution, but it was a bitter pill that the Nazi leadership was unwilling to swallow. To fix the problem, the Wehrmacht needed to redesign almost every transport vehicle in the inventory to accommodate larger, more ruggedized, low-tolerance joints, completely retool the production lines at major factories, a process that would take months, halt vehicle production in the middle of a total war to allow for these changes. To the high-ranking officers and party officials, this was heresy. Hitler's victory through will philosophy had no room for halting tank production because of a bearing. They believed that if they simply pushed harder, if the soldiers were more disciplined, and if the mechanics worked longer hours, the mechanical friction would be overcome by German spirit. The report was filed away. The warnings were dismissed as defeatist talk from armchair engineers who didn't understand the realities of the front. The war could not wait for a redesign. But while the factories continued to churn out the same flawed designs, the supply lines, the very veins of the army, were already hemorrhaging beyond repair. As 1943 turned into 1944, the silent collapse transitioned into a very loud and very public catastrophe. On the maps in Berlin, the German lines still looked formidable. Divisions were marked as full-strength icons, but on the ground, these were ghost formations. In the great sweeping Soviet offensives that followed the disaster at Stalingrad, the world saw something strange. Entire German divisions were being overrun not because they were outfought in the heat of combat, but because they were immobile. The tragedy of the German retreat was not one of cowardice, but of mechanical paralysis.
In sectors where the Red Army struck, German commanders would order a tactical withdrawal to a new defensive line. But when the orders came, the trucks wouldn't move. The artillery, essential for covering a retreat, sat silent because the heavy tractors meant to tow them were slumped in the mud with shattered U-joints. Infantrymen were forced to watch as their support vehicles, loaded with the food and ammunition they desperately needed to survive the night, were set on fire by their own crews to prevent them from falling into enemy hands. These weren't combat losses, they were logistical suicides. The Soviet offensive succeeded faster than anyone, including the Stavka in Moscow, had expected. This wasn't solely due to superior Russian tactics or the overwhelming weight of their numbers. It was because the German logistical machine failed first. A panzer division with 50 tanks is a terrifying force. A panzer division with 50 tanks and no fuel trucks is merely a collection of very expensive bunkers. The soldiers of the Reich, who had been told they were the masters of the war of movement, found themselves trapped in a static nightmare. They died in the snow, miles from the nearest supply dump, all because of a 3-inch piece of steel that no one in the high-walled offices of Berlin thought mattered. The clockwork precision of 1941 had been replaced by the silence of the graveyard. When the guns finally fell silent in May 1945, Allied technical intelligence teams swarmed over the remnants of the German military machine. They interviewed the captured engineers of the Ruhr and inspected the thousands of abandoned vehicles littering the roads from the Volga to the Elbe. The British and American analysts reached a conclusion that was as brutal as it was enlightening. Germany didn't lose the war because of one singular bad strategic decision, like the halt order at Dunkirk or the obsession with Stalingrad. Those were symptoms. Germany lost because of a fundamental institutional assumption, the belief that the war would be short. The German military-industrial complex was built for a sprint, not a marathon. They designed their vehicles with the arrogance of a jeweler, creating parts that were perfect for a laboratory but too fragile for a wasteland. They assumed that their parts wouldn't need to last forever because the enemy would be defeated long before the metal reached its fatigue point. They believed that firepower and tactical brilliance were the kings of battle, while logistics was a secondary, almost clerical concern. History, written in the rusted hulls of the Opel Blitzes and the bleached bones of the horses that eventually replaced them, proved otherwise. The lesson learned by the post-war world was clear. A tank is only as good as the truck that feeds it. A truck is only as good as the smallest bearing in its drivetrain. And a war is not won by the fastest advance, but by the army that can keep moving when the roads disappear and the precision fails. In the end, the most powerful military machine in the history was brought to its knees not just by the weight of empires, but by the smallest piece everyone forgot to protect. It is a haunting reminder that in the grand theater of war, the difference between an unstoppable conqueror and a stranded casualty often comes down to a few ounces of steel and the humility to respect the mundane.